So this is kind of a follow-up for Matt Parker's video, is there an equation for a triangle? I really recommend you to watch this video first because it's very interesting and it's a follow-up, so you might just better watch the first video first, but you could also watch it later. I don't care that much. So in this video Matt uses the sine function, not the sine function, the sine function. And he says that some people would not consider the sine function to be a standard operation, and he defends it pretty well.
I would argue the sine function is no weirder than the absolute value function, and no one minds that I was using the absolute value function for the equations for circles and squares, even though it's a weird function. It's not like a standard operation, because what you do to the input changes depending on what the input is. So the absolute value function is basically, if the value is below 0, return the negative version of it. If it's equal to or greater than 0, just return it as it is. And so it's this weird piecewise function, but for some reason, people are happy to draw the line, or rather two lines, one on each side, at absolute value, but they won't go with the sine function, which is the same thing, except instead of returning negative x or x, you return negative 1 or 1. And I'm happy to allow that.
In this moment I was thinking to myself two things. The first, that you could just say that the sine function is x divided by its absolute value, and also that the absolute value of x, given that x is real, could be just defined as the square root of x squared. So, like, what's the problem? But of course Matt was one step before me.
If you're a real stickler and you don't like the sine function, but you will accept the absolute value function, then there's kind of a workaround, because one way you can make the sine function from the absolute value function is to get a number and divide it by its absolute value. And that will give you 1 if it's positive, and it will give you negative 1 if it's negative, except that breaks, totally explodes if you have a 0. And we don't want something where we're trying to plot a triangle and it explodes each time we put a 0 in the wrong place.
I was pretty satisfied with this explanation, but after finishing the video I was still thinking about the sine function and how to define it. And then it hit me. What if there was a way? What if there was a way to make it work? What if we could prevent the denominator from getting to 0 by adding a number when and only when x is 0? Which function gives us a number that isn't 0 when and only when x equals 0? Oh, right. 0 to the power of any number gives us 0, except for 0 to the power of 0, which gives us 1. Only one problem. It works only when x is not negative, because 0 to the power of any negative number is like dividing by 0. I guess you saw that coming. By using the absolute value of x instead, we extended a function to be defined for any value of x. Now we really just have to plug it into the denominator to prevent it from getting to 0 when x equals 0, and we made it work for any value of x, even 0. We could actually use the definition of the absolute value of x being the square root of x squared, and then we don't even need the absolute value of x to define the sine function. We actually made the sine function only with regular operations. I really hope you found this video interesting. Let me know what you think in the comments. Thanks for watching.